Hello friends, very good morning. Myself Dr. M.H. Annaya, and in today's video we are going to work out a problem on the development of the lateral surface of a cone which is being cut horizontally by this line, and there is an arc like thing here. So this is throughout the depth of the solid, is also throughout the depth of the solid. And friends, for any problem on these cones, first of all, you have to find out the arc subtended by the cone at the apex O. So for this, we have a formula given by theta is equal to small r by capital R into 360 degrees, where R is the radius of the base. So this is totally 60, radius is 30. So this is 30 divided by R. R is the length of this slant generator or the end generator, which will be true in length. So this is the length of this slant generator R that can be obtained after construction of this triangle O dash, this figure. 360 is a constant quantity, so you will get this value. So theta we have calculated. After calculation of theta, you will have to write a sector with the center O. So I am going to write a sector here like this, with that included angle theta equal to whatever the value you get from that formula, you have to put it there. And this is how the cone looks when it is not cut by either the section plane or this curve, which is also can be considered as a section plane. So friends, let us write down the top view of this cone with the diameter equal to 60 millimeter. So we will write horizontal and vertical lines through this. It is divided into 4 parts now. We will further divide it into 8 parts. So these are all the divisions, and we can call this as A, B, C, D, E, F, G and H. O is the apex, O dash is the front view of that. Friends, now we have divided the circle into 8 equal parts. So also this sector having theta will be divided into 8 equal parts. So now this is divided into 4 equal parts. Further divide each of these into 2 equal parts by the bisection of that angle. And friends, we will name this front view by projecting all these points. That is A dash. This is B and H will come together somewhere here. So we'll call it as B dash, H dash. This is C dash, G dash. And this point is D dash, F dash, F dash. Last point is E dash. And this sector we have writing here with R as the length, that is R, and this length is also R. This is the sector we have drawn. And we will name all these points on the base as A, B, C, D, E, F, G, H, and A. OA and OA, the end lines should have the same numbering. So they have the length equal to R, the length of the true generator. Friends, let us move on to the front view and see this horizontal line, see S1 and S1, can be considered to be a horizontal section plane which is normal to VP and perpendicular to HP, and it is cutting all the 8 generators. That is, before that, let me join these generators. These are the generators we have got, and all these generators are all cut at the same height from the base like this. OA, OB, OA, see, up to OH, all are cut. And since this is the true length and this section plane is parallel to the base, you can take this measurement on all the generators from this apex, or you can take this as center, this much radius, and strike an arc, because all these are at the same distance. So this is how the horizontal section plane has cut this. This part is removed. We don't have the portion above. That is to say, this portion is not there. Then friends, let us come to the second section plane. The second section plane is this, a curved section plane, it can be assumed. So it is cutting the base at these two. So let us write down a vertical line from there and see where exactly it is cutting. Friends, it is cutting the base here on HG, on BC. On HG, nearer to that H, it is cutting. So on HG, nearer to H. HG, nearer to H. You get a point here. Similarly, on BC, nearer to B. On BC, nearer to B. So this gap and this gap are the same. Next friends, it is not cutting any, it's cutting these generators. That is OC and OG are cut here. These are not the true length. I shift that point to the last generator, that is OE, and take this measurement on OC and OG. OC and OG, I just mark the distance, OC and OG. Friends, it is not cutting this generator, but it is cutting the base here. To know exactly where it is cutting, same procedure, it is cutting the base on this portion FE and also on portion CD. On FE, on the base nearer to F, on FE nearer to F. FE nearer to F. It is cut here. And similarly, on CD nearer to D. On CD nearer to D. It is cutting here. And friends, if you join all these points by continuous curve, that is, you have 2 points on this, 2 points here on the base. So if you join all these by smooth continuous curve like this, this is one, and exactly similar to that, we are going to have one more curve. So these two will be exactly identical if you make them to scale. Friends, here this portion OA, OE are intact. So I would like to show them by the lines like this. This portion is this. Similarly, this side, this is retained, and this bottom is also retained here. Friends, and these lines won't exist, even this is not existing, have to be shown by very thin lines. So friends, this is how the development of this part between S1, S1 and this R appears in the development. I will say this as development of P, the portion between these two of the cone. Friends, I hope the presentation was interesting. Please go through the complete video, and if you like the video, please share with all your friends without fail. Have a nice day, and I thank you very much.